So I call these radical equations. They are specifically, so the term radical refers to anything that has one of these. That symbol is called a radical. And understand that that is called a square root. If I put a number here other than the invisible 2, it would be like a cube root, right? It's still considered a radical. We, at least for the foreseeable future, are only going to talk about the square root. So I call them radical equations, but more specifically, we're just going to be solving square root equations. And if you guys tackle this with the greatest of ease, then perhaps we'll move on to some cube roots and fourth roots, but we should be fine with just the square roots, okay? So an example would be this, the square root of 4x plus 61 plus 15 equals 22. And even though you've never done this before, I have a feeling you know what to do first. There's a very recurring theme in algebra, in mathematics, and you have probably a spidey sense that just tells you what to do. What do you suppose we ought to do? Take a shot. Yeah, I mean, it just feels right. I mean, we've been down this road before. We've seen it with exponential equations. We've seen it with absolute value equations and inequalities. The idea is you and I both know that this is our focal point, right? Even though we've never seen it before right now, we just know that's a focal point. So we need to get the 15 to the other side first. So we're going to subtract 15 from both sides, leaving us with this. If you don't write it down right now, at some point you need to, eventually you just will write down the fact that you need to get the radical by itself, right? And we've heard that so many times. That's been our battle cry for so many things. Get something by itself before you proceed. So getting the radical by itself is the key here. All right. Let's throw this out again at you guys. What do you suppose we could or ought to do next? This is not a basic algebra problem. I mean, obviously, we want to subtract 61 and divide by 4. That's the training that is just ingrained in us by this point. You know, end of your junior year, you just know what to do. We just can't do it right now because the 4x and 61 are trapped in jail. So, what do you suppose we could do to change that? I think what you meant is just square both sides, right? We know that things can be taken away. Everything in math that you see can be made to go bye-bye, right? And square roots can be eliminated by using their inverse, which is called a square. Squaring and square rooting are like plus and minus or times and divide. They can just undo each other. So if I square both sides, that leaves me on the left with just what was inside, the 4x plus 61. And then what's 7 squared? 49. And it immediately morphs from an algebra 2 problem into like an eighth grade math problem. It just happens, bam, you do one thing, and now it's just a basic two-step equation. Now the things we wanted to do a minute ago, we can do. So basic math, let's subtract 61 from both sides, which gives us 4x equals negative 12. And then we divide both sides by 4, and we get x equals negative 3. And anytime you're working with roots, you want to quickly verify before you box up your solutions. We've seen this before as well. Before you box them up, you want to make sure that they work. And this will become more and more important as we go through the next few days. But it's a habit that we should just form right now. So we want to make sure that we go back. I would usually go back to the beginning, but as long as you go back to anywhere above the purple line, because the purple line is the separation where we squared. And if bad answers are going to show up, they're going to show up during the squaring process. So anywhere above the purple line would be fine. Which one would you guys prefer? First or second? Okay, I'll do the second. Um, so I'm going to go right here where this green arrow is pointing, and I'm going to change that x real quick into a negative 3. And then let's just math it out and see if it seems legit. So what is 4 times negative 3? Right here. And what's negative 12 plus 61? 49. And what's the square root of 49? It checks out. So you can have a box. One thing that's going to pop up throughout the next few days is this. To be clear, when I ask you for the square root of a number, like the square root of 9, what is the answer? It is 3. And there comes a point where you want to think that it's either positive or negative 3. In this context, that is not true. We're only talking about what's called the principal square root. So if Coulter's sitting there and he says, God, well, what's the square root of 49? Couldn't it also be negative 7? Not in this context, it cannot. Okay, that's only applicable when um, it's in like quadratic equations is when we consider that, when we square root ourselves. So in this case, the square root of 49 is 7, checks out, gets a box, on to the next one. Okay, let's go again. Round 2. Square root of 5x minus 11 minus 5 equals negative 3. Step 1. Correct. So we get the square root of 5x minus 11. And we are adding 5 to both sides. Let me show my work, because some of us are still forgetting to change signs when we move things across equal signs. So negative 3 plus 5 is, of course, 2. And then from here, it's just the process, square both sides. What does the left side become if we square it? What does the right side become? Yep. And then it's just a real basic algebra problem. Add 11 to both sides, we get 5x equals 4 plus 11 is 15. Divide by 5, x equals 3. And as always, before we box it, it's going to be that same thinking. We'll either box answers or cross answers. We will not leave answers just sitting out exposed. They will be boxed to state we have checked them, they work, or they will get crossed out to state we have checked them and they don't work. Okay. So just super quick, stick it in there. Put a 3 right up here where the green arrow is pointing. What's 5 times 3? 15 minus 11 is 4. Square root of 4 is, and 2 minus 5 equals, works. So x equals 3 can have a box. Okay. So you can put it in the very original problem if you'd like, or you can put it in the one before, again, provided that you do it before the squaring. Any sort of rooting or exponentiation is where the extraneous solutions, the bad guys, show up. So make sure you check your answers before that. They'll always work below the purple line. That's not what we're interested in. It's do they work before the purple line? All right, round 3. The square root of x plus 8 plus 2 equals 1. Sorry, this probably feels repetitive, but I'm about to throw a curveball at you. Spoiler alert. What do we do first? Yeah, I mean, that's not up for debate. We have to subtract 2 from both sides. Like what we said 5 minutes ago about getting the radical by itself, that's not going to change. Okay, so we're going to eliminate the 2. Subtracting 2 from both sides gives us the square root of x plus 8 equals what? Correct. And what do we do from here? We don't. We stop right here and state that there is no solution. And the logic behind this, by the way, if you did go further, all hope is not lost, and I'll show you what I mean. But if you're taking a quiz and you forget this, then it's okay. I'll show you, like, you could still come to the same conclusion. But I talked about this. I kind of threw this in a few minutes ago. Bless you. What is the square root of, I don't know, 16? 4. What's the square root of 1? 1. What's the square root of 0? 0. What's the square root of 100? 10. Do you notice something about every number over here in this column? They're all non-negatives. The lowest they can get is 0. So the moral of the story is no matter how many lifetimes we spend, we're never going to find an x value that we can put in here so that the square root of this will come out to be -1. The lowest the square root is going to quote unquote produce is going to be a 0. So if you get the square root by itself and you get a negative number, you can stop and just say no solution. But let's just pretend that we forgot and we pressed on. And we did what you guys said to do, and we squared both sides. If we square both sides, on the left side, we get x plus 8. What do we get on the right side if we square -1? We get 1. Okay, and then subtract 8 from both sides. What do we get for x? 1 minus 8. Good. And so that answer sits and waits for us. Okay, so even if you missed your opportunity earlier, just take a quick moment and check it. And if you put -1 or -7, excuse me, up here where the green arrow is pointing, what's -7 plus 8? 1. And what's the square root of 1? And what's 1 plus 2? Not 1. So you could catch it later as well. Okay, and so you'd come to the same conclusion if you missed your shot early. Obviously, you want to take your shot right here. This is your moment to save some time and just say no solution, right? But as always, if we get to the end of a problem and anything that could have been a solution is not going to work, then we would still have to say like the answer. You can't just cross everything out and assume that people know. Like you have to make your claim that there is no solution. Okay, watch out for that. And then our fourth example, before we hit the next level, we're kind of covering the bottom 2 levels today. So let one more of these simple ones here. The square root of 3x minus 6 minus 4 equals -4. Step 1, add 4, giving us the square root of 3x minus 6. And what's -4 plus 4? 0. Can I get a square root to equal 0? What's the square root of 0? The answer is yes. This is not a no solution situation. The only time we're going to jump to that conclusion at this point right here at this crossroads is if the number on the right is a negative. That's what can't happen, but it can make a 0. So at this point, we would proceed and we would say, okay, let's square both sides. I'm going to square the left side. I'm going to square the right side. The left side being squared is 3x minus 6. The right side being squared doesn't look like he changes. And again, instantly it morphs into a very basic math problem. Add 6 to both sides. Divide by 3. Let's check it and see if it's legit. So again, anywhere above the purple line would be fine. Which do you prefer, the OG or the modified? Great, good input on that. So I'll go ahead and go right here. And if I put my 2 right there, what's 3 times 2? 6. And what's 6 minus 6? And what's the square root of 0? It works, so it can have a box. So that's bottom level, right? If we're like climbing a mountain here, that's like base camp number 1. Okay, so that's just the basics of how to solve a square root equation. Isolate the square root, square both sides, solve what you get. Any questions there? All right, let's go up a level. So these are what Delta Math will refer to as level 2. Those ones before that we just did would be level 1. So when you see these in your Delta, level 1, level 2, that's what it's talking about. And these ones are a little bit harder. Instantly, you see it and you realize, okay, this is going to be a level up because when I square the right side, I actually have to do some math, right? Squaring the right side before was child's play, like, ooh, what's 5 squared? What's 1 squared? Like, that's easy. But this is a math thing. So let's start by first acknowledging that, yes, the square root has been already isolated. So I don't need to move anybody away. So I'm ready. Got the green light to do this. Let's square both sides. And this right side should raise a flag. Got to be on your toes. This is the umpteenth time we've revisited this concept, the square, square, multiply, double concept. So let's start with the left side. If I square the radical just lifts away. The squaring is essentially like a crane that comes in and just grabs the root and drops it in a dumpster. So we get 3x plus 16. But boy, oh boy, do we have to be careful on the right side. And as I said before, the most offensive answer you could give for the right side would be x squared plus 4. Don't do that. Okay, I have to erase that. That's terrible. So you have options here. Option one is if you have memorized the square, square, multiply, double process, then do it. Option two, if you're like, I don't know, it never clicked with me, is just be safe. Take your x plus 2 squared and write it out. Go algebra 1 mode on this little sucker and just write it out like this so that you don't do anything crazy. Okay, so let's go through the whole 4-step process. What's x times x? X squared. What's x times 2? 2x. Just working my way methodically through the foiling process. What's 2 times x? And then finally, what's 2 times 2? So what does the right side actually equal? Good. And you can understand from a teacher's perspective how heartbreaking it is when I'm trying to teach you radical equations and you mess this up, right? So this lesson is not about square, square, multiply, double. This lesson is about something else. So let's not let something silly like that be the reason why we struggle on something new. We agree. So our training kicks in and we realize now this is not like the others. This is not an 8th grade math problem. This is a quadratic equation. What's our thinking when we see a quadratic? Yeah, move all your stuff to where the x squared is positive. Good job, Parker. So we're going to leave x squared here. How many x's will we have? Just one, because we're going to subtract the 3x across. And what will our constant, our c term be? Good job. Right, so you see why this is a level 2 and not a level 1. There's a lot more meat on this bone. And levels 3 and 4 will be even quite a step up from this. So we're going to work hard here today to practice these levels. We have to factor, right? And everything will be factorable, by the way. No, nothing's going to cause you today. If you get to one where you feel like you need to use the quadratic formula, you done boo-booed. Could it happen? Of course it could, yes, but it's not going to happen, not in this class at this point, okay? So if you get something ugly, go back and check your work. So if I factor this down, build my shells, what are my signs? 1 plus, 1 minus, and what are my numbers? Correct. So what are my wannabe solutions? So x maybe equals -4. X also maybe equals +3. But again, we're not committed to those yet because we have to do our due diligence and go see, are they legit? So we're going to head back up. We're going to carry those numbers back to the beginning, -4 and +3. And we're going to put them anywhere above the purple line, which in this case, there's not a lot of options. There's only one equation above the purple line, so that's our only option. So let's start with -4. And let's put it where this green arrow is pointing. -4 goes right there. So just kind of follow my pen. I'm kind of wiggling it around. What's 3 times -4? What's -12 plus 16? 4. And what's the square root of 4? 2. So we're sitting here now with 2 equals, but there's a variable, an input on the right-hand side that needs to be filled in as well. So this time, go to where the yellow arrow is pointing, right there, and put in a -4. He's our candidate. What's -4 plus 2? And last I checked, 2 does not equal -2. So we see an example here of a situation in which an answer doesn't work. And we found one earlier, but honestly, we should have caught it earlier in the problem, if you remember that. But this one is just straight up. I had no idea, but now I see that you, sir, need to cross out. Okay. You're not going to see the no solution, extraneous solution situations here early because of the variable. The fact that this thing I'm circling in purple is a variable means I don't know what the right side equals. So I can't make those early judgments. X could be anything, right? So we have to wait on these. Let's go check the other number, which is 3. So again, go to where the green arrow is pointing. If you put it where the green arrow is pointing, what do you get for, what is that, 3 times 3? Uh, yeah, I think, right? 3 times 3, 9, and then 9 plus 16 is 25, and the square root of 25 is 5. Okay, and then on the right side, go to the yellow arrow. What's 3 plus 2? 5. And 5 does equal 5. Therefore, we see a situation here where one of the answers does work and one of the answers does not work. So our answer to this problem is just x equals 3. All right, 2 more examples, each with very specific purposes, and then I'm done. Then we're done. Next one, we have the square root of 65 minus 8x plus 9 equals x. Step 1. Right. Yeah. So let's not lose sight of the original step 1, which is get the radical by itself. So if I subtract that 9 on this side, it goes away. On this side, it can't go with the x. So we do have to leave it as a binomial. So it's going to be 65, my root of 65 minus 8x equals, and then this side you just have to write as a difference. You're not going to try to like combine those terms or something like that. And then the process kicks in. It's time to square both sides. So if I square the left side, I got this one. And then the tricky one is the yellow one. And it's not tricky once you practice it and, quit falling for the trap. What is x minus 9 squared?
X.
Minus what? Minus 18x. Good job. And if you are sitting there with your jaw hanging on the floor wondering, oh God, I'm cooked. How did they get that? Again, it's just red and purple. It's red, purple. Red squared is x squared. Purple squared is 81. Red times purple is negative 9x, double it, negative 18x. So then again, if that's too fast for you, then just go off to the side and write x minus 9 times x minus 9. Right. But again, what a shame to not actually get to do the math problem because you're botching something like that. So don't let that be your hang up. So let's move all of our junk to the right side. So we got x squared. How many x's? Nice job.
Plus 6.
Nice job. Good basics. Well done. And it's just a factoring problem. And this looks pretty factorable to me, right? This is not our first go at this. So we know to build shells, what are the signs going to be? Totally a minus and another minus. And what magic numbers will work? 2 and 8. 8 and 2, 2 and 8. And either order won't matter in this case. So our candidates for solutionosity are x equals 8 and x equals 2. And again, you won't spy these early. You have to see this through with the variables on the right side and go back and vet them later. So let's check 8 first of all. So let's go back to the beginning of the problem and let's check 8. Oh, and we can go to the very beginning. I'm going to go to this one since I just erased the other part. So as long as it's pre-squaring, it's okay. So if I put 8 right there where the green arrow is pointing, what's 8 times 8? 64. What's 65 minus 64? What's the square root of 1? 1. So we just sit here and wait now. And we say 1 equals what? And then you put 8 in the other side. What's 8 minus 9? And 1 does not equal negative 1. Therefore, I'll go down to where 8 is at, and I'll give it a cross. Okay. Again, the word for that kind of solution, if you're interested in learning this word, it's come up before. I don't care if you really know it right now, but those are called extraneous solutions. They happen in mathematics when we do funky things. with exponents and radicals or absolute values sometimes. When we do funky things, extraneous solutions can kind of sneak in through the back door. Let's go check two. Can you tell me right now why two just won't work? You can already tell. You don't have to do any, well, a little bit of third grade math, but why can two not work? Nope. Or unless you want to be more specific about that. Yes, this right-hand side is going to be negative. And so I don't even have to really, I mean, if you don't know 2 minus 9 is -7, you're pretty cooked anyways. But like if you put 2 into that purple box, you're going to get -7. And as we've discussed, the square root is never going to produce a -7, right? So without actually vetting it completely, I have enough evidence to say that you're not going to work either. So we would say in this case, another extraneous solution means no solution. Right. And then our last example. Yeah. Figured by this point, we wouldn't want to like subtract one from both sides. So it's just ready for us. It's just waiting. What are we going to do? Square. Square the whole thing. What does the left side become? Go ahead. Right side, I'm ready. Love it. That's how you square, square, multiply, double like a boss. All right. That cannot be the reason we struggle. If it is, listen, I'm here for you. You need to just come see me and say, I want to do it the quick way, but I'm kind of sucking at it. I'll practice it with you. We'll practice 20 of them in a row if we have to, so that that's not a holdup for you. Okay. And now again, it's pretty repetitive. Everything is going to go to the right. So the x squared is just going to kind of kick it there. How many x's will we have? Correct. And what will our constant term be? +8, because we added 7 to both sides. Those little fundamentals we learned a couple of years ago in Algebra 1, they just never go away, right? Moving things across equal signs. And then we factor. What are the signs? What are the numbers? 8 and 1. Works perfect. Okay. And our candidates for solutionism are 8 and 1. So we head all the way back up to the north and we go check them. We vet them one by one. So let's check 8. So green arrow first. If you go where the green arrow's at, what's 7 times 8? 56. And what's 56 minus 7? 49. And what's the square root of 49? 7. And now go to the yellow arrow side and put 8. What's 8 minus 1? 7. Last I checked equals 7. So 8 can have a box. Good job, 8. You work. Again, that whether or not one of them works has zero implications as to whether or not the other will work. These guys travel independent of each other. So let's go check one. And nothing obvious here stands out. So let's go to where the green arrow is first. What is 7 times 1? 7 minus 7. Square root of 0. On the right-hand side where the yellow arrow is pointing, what's 1 minus 1? 0 does equal 0. So I wanted to make sure you got to see an example today of a no solution, a one of them works, and a both of them work, because they're all three going to come at you. Okay. Do you have any questions about that process? This first assignment is on Delta Math, and it's there. I think it auto assigned itself like 15 minutes ago. So you'll see it. It's called assignment number 42. You'll see it. It'll say like A2 number 42 sometimes. So that's what we're going to work on for the rest of the hour today and perhaps part of the hour tomorrow. We'll see. Okie dokie. I'll pause this and I'll keep it going. And if someone says, oh, can we go over this? Then I'll unpause it. If not, that'll be the end of the recording.